Okay, in this video we're going to have a look at how we handle expansion of brackets when we square a bracket that contains surds. I put a reminder up here just to take us back to a previous video where we looked at where we expand brackets, where we square brackets. And we've got a plus b all squared, looking at the plus for now, equals a squared plus 2ab, which is 2 times the product of a and b, plus b squared. Ignoring the minuses for now, we'll use those in a minute. Okay, so if we looked at this example, we've got two surds, the sum of two surds, root 5 plus root 2, all squared. A classic mistake, and what might be tempting for many people to do, is to think, okay, well that is root 5 squared is 5, plus root 2 squared is 2, so the answer is 7. That's not what we have here, because actually, before we do that squared, we're looking at the sum of these two surds. So it's root 5 plus root 2, all squared. And we're going to use this formula to do it. So if this is a and this is b, that expands like this. A squared, root 5 squared, equals root 5 times root 5, equals 5, plus 2 times the product of a and b. So that's 2 times by root 5 times by root 2 plus b squared. So root 2 squared is 2. We can tidy this up a little bit here. If we look at our integer numbers, our rational numbers, we've got 5 and a 2, that is 7, plus, what do we have here? 2 times by root 5 times root 2. We know that that is 2 times by the square root of 5 times 2. So we have 7 plus 2 root 10. Okay, slightly more complicated over here for a couple of reasons. Firstly, we have slightly more complicated surds within the bracket, 3 root 2 and 2 root 3. We need to be a bit careful about how we handle those in a minute, but we've also got a difference. We had a sum here, we've got a difference here, and that's why I've put in pink underneath here minus signs, because if we're dealing with a minus b bracket all squared, then we have to have a squared minus 2ab, 2 times the product of a and b, plus b squared. So let's use that over here. That equals a squared. This is where we need to be careful. If we square a, that's 3 root 2 all squared. I'm going to write it like that for now so that we don't go wrong. Minus 2 times the product of these. So minus 2 times by 3 root 2 times by 2 root 3 plus b squared plus 2 root 3 all squared. So I've applied that formula over here to expand this, but now I need to actually square these numbers and see where that goes. This is where we need to be very careful. If we square 3 root 2, multiply that by itself, we're going to end up with 3 times root 2 times 3 times root 2. So let's reorder that. 3 times 3 is 9. Root 2 times root 2 equals 2, which actually, of course, is just 18. Minus. Okay, let's again reorder this. So first of all, we deal with the rational number parts. So we've got 2 times 3 is 6 times 2 is 12 times by root 2 times root 3. So I'm starting to do some of the multiplications and I'm reordering things to make things a little easier to handle. Plus, just like we did over here, 2 times root 3 times 2 times root 3. So our 2 times 2 is 4. Root 3 times root 3 is 3. So if I bracket these three terms up so we can see how they're progressing in this calculation, 9 times 2 is 18. Minus 12 times the square root of 2 times the square root of 3 equals 12 times the square root of 6. Plus 4 times 3 is 12. Final step, let's just tidy this up. So 12 plus 18 is 30 minus 12 root 6. And I think you can see there how important it is to be very, very careful when you're expanding surds in this way.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.